Hello there. We are Teammate and we're going to explain mechanics. Mechanics is an area of study in physics aimed at explaining the motion of bodies. This definition is considered to define fluid mechanics, which is the branch of mechanics that studies the movement of fluid. Fluid mechanics plays a very important role for engineering, as it allows describing the movement of fluids through pipes, vital for fluid pumping and transport systems. Throughout history, our lives have been polished and improved all thanks to mechanics, not only involving the movement of bodies, but overall the study and principles of such.
A non-Newtonian fluid is a fluid whose viscosity varies with the temperature and the shear of applied. As a result, a non-Newtonian fluid does not have to define a constant viscosity value. Unlike a Newtonian fluid, although the concept of viscosity is commonly used to characterize a material, it may be inappropriate to describe the mechanical behavior of some substances, especially non-Newtonian fluids. These fluids can be best characterized by other rheological properties that have to do with the relationship between stress tensors under different flow conditions, such as shear stress conditions. Examples: soapy solutions and fat-based food such as butter, cheese, jam, ketchup, mayonnaise, soap, cherry caramel, and yogurt. Natural substances such as magma, lava, and extracts such as vanilla. And biological fluids such as blood, saliva, mucosa, and synovial fluid.
Hi, I'm Eric and I'm going to show you how to make a non-Newtonian fluid. First, we're going to need a bowl, cornmeal, and some water. The first step is to put the corn water in the bowl. Then we're going to put some water. And then we have to mix. Okay, when we apply pressure, it acts like a solid, but then it acts like a fluid when the pressure is liberated. Let's just see it like this.
Hydrostatic pressure is the pressure that a body submerged in a fluid undergoes, due to the column of liquid that it has on it. Assuming that all points in the fluid are in equilibrium, the hydrostatic pressure is directly proportional to the density of the liquid, the depth, and to the gravity. Therefore, the pressure will be higher the denser the fluid and greater the depth. Furthermore, the difference in hydrostatic pressure between 2 points in a fluid only depends on difference in height between them. An example of this physical phenomena is when we put water in a container and the hydrostatic pressure increases as the depth within the fluid increases. It can be verified by seeing that the speed with which the fluid comes out of the container with holes at different heights is higher, the lower the hole is. Because of hydrostatic pressure, any body immersed in a fluid is subject to forces that act perpendicular to the body and whose value increases with depth.
Cavitation is a physical phenomenon that commonly affects mechanical fluid drive devices. It happens due to the formation of bubbles of vapor or gas within the liquid, caused by the variations that explain experience in its pressure. Cavitation is a physical phenomenon by means of which a liquid under certain conditions goes to a gaseous state and a few moments later it goes back to a liquid state. This phenomenon has two phases. Phase 1. Change from liquid to gaseous state. Phase 2. Change from gaseous state to liquid state. Due to the narrowing of the passage section at the regulation point, the speed of the fluid and therefore its kinetic energy increased considerably. In the contracted vein, the remaining pressure energy and therefore the local pressure decreases considerably since the total energy must remain constant.